We're looking at Chapter 8 in our elementary statistics book. So if we open up to our Chapter 8 here, on Chapter 8 we're talking about hypothesis testing. Okay, so a quick review over here. Basically, estimating values of population parameters using confidence intervals was what Chapter 7 talked about. This chapter introduces two major activity of inferential statistics, testing claims about population parameters. The main objective is to conduct hypothesis tests for claims about a population proportion, a population mean, or a population standard deviation. Okay, so what we're going to be doing is we're going to be creating and figuring out how do we test a hypothesis about something, on whether it be that we want to know that 50% of the people that play the lottery lose. So we want to test how do we test these claims. So in section 8.2 we look at the basics of hypothesis testing. Identifying the null hypothesis and the alternative hypothesis from a given claim and express both in symbolic form. We're going to calculate the values of the test statistic given a claim and sample data. Then we'll choose a sampling distribution that is relevant, either find the p-value or identify our critical values, and then we will state a conclusion about this. Okay, so if we look at part 1 here and we talk about the definition. Okay. In this definition, in statistics, a hypothesis is a claim or statement about a property of population. So a hypothesis test, or a test of significance, is a procedure for testing a claim about this property of population. So as we start considering what's going on here, we do have to realize that we're going to have to be figuring out everything that is in relevance to our part in here. So when we start considering everything, we start talking about the rare event of inferential statistics. Okay, so if under a given assumption the probability of a particular observed event is extremely small, we conclude that the assumption is probably not correct. Okay, so looking at the steps going forward for hypothesis testing. Here we have steps 1, 2, and 3. Okay, we are going to identify the null and alternative hypothesis. The null hypothesis is a statement of the value of population parameter, okay, such as our proportion, mean, or standard deviation, is equal to some claim. Okay, so I'm going to stress this, equal to. So the null hypothesis, or H naught, is equal to some sort of claim. Now, it doesn't mean that it's a claim we're testing, but we do test the null hypothesis. So we test the null hypothesis directly in the sense that we assume it is true. And then we reach a conclusion to either reject or fail to reject. Okay, so basically we're going to assume that this null hypothesis is going to be true, and then we're going to test towards it. Because we're assuming that it's true, we will never accept, but we will fail to reject. Okay, so we either reject that, oh, if this is true, it's not working, so it's not going to be true. Or if we're testing it and it turns out that, hey, it looks like it's working, we're still going to say, hey, it's not truly true, but we'll fail to reject that it can't be, okay? And then our alternative hypothesis, so our statement for our alternative hypothesis, once again here, is going to deal with the parameter to show that somewhat differs from the null hypothesis, okay? So our alternative hypothesis is either going to be less than, greater than, or not equal to the value. So if I come over here, if we remember back, our null hypothesis right up here, p equals 0.5. So alternative would be is greater than, less than, or does not equal. And some of this depends upon what our claim is going to be, or what we're trying to hypothesize towards. If we're claiming that something equals this, our alternative is not going to equal. If our claim is that we're going to be above something, well then the alternative will be above, but then the null will equal then directly. And so then we start testing towards. So on page 399, this is a page you're going to want to note and make sure, you don't need to write everything out, but make sure you bookmark this page because it does have a bunch of relevance in here. Now once again, depending upon what we're working with, if we're working with a p-value method or we're working with a critical value method, it's still going to follow the same kind of parameters as we start going through. One of the biggest things down here at the bottom is when we talk about the confidence interval. We talk about our significance level for hypothesis testing, 0.01, 0.05, 0.10, and then we talk about our test under two-tail, one-tail, 99%, if it's two-tailed, 98%, once again, is relating to the significance level of 0.01. So this is a good table that we will be referring back to find our values for what's going on. If we turn over step 4 here now, step 4 basically asks us to select the level of significance for alpha. Okay, so do we want to be 98%? Do we want to be 99%, 95%, 90%? What is this critical value going to be? Then we're going to look at step 5. On step 5, once again, this table right down here, table 8.2, talks about our different parameters and the tests that are performed with those. So once again, if we're doing a population proportion, P, we're relating it to our Z, once again our requirements, and then we have our test statistic over here. If we have population mean, once again t-test, if we don't know that standard deviation, and then we have that test statistic value here. If we have that normal, once again sigma's known in here, we could relate our z value here. And then if we're relating for a population standard deviation of variance, we're going to use our chi-squared test. And then we have our chi-squared value over here for our test statistic. Once we figure out what that is, we actually, on step 6, then we'll find the value that we're relating to. So again, this is going to vary per what test we're doing and what value we're trying to relate to. Some of the things to remember in here in our hypothesis test is when we start talking about our critical regions. Okay, so remember, a critical region corresponds to the values of the test statistic that cause us to reject the null hypothesis. Okay, so basically we look at a possible two-tailed, if we can be above or below something. We show this over here. A left tail, once again, the null hypothesis would be less than this, or a right tail, if that critical region is extreme in that higher area, then that null hypothesis would be greater than. Okay, so they have a nice hint right here. It says determine whether a test is two-tailed, left-tailed, or right-tailed. Look at the alternative hypothesis and identify the region that supports that alternative hypothesis and conflicts with the null hypothesis. And then when we start looking at critical values, regions in here, remember we talked about that p-value, and you never heard this before, but the p-value, once again on bottom of page 402, talks about the critical region in a left tail. The p-value equals the area under the left of that test statistic. If it's a right tail, then the p-value is greater than, and then in a critical region in two tails, p-value is twice the area of the tail beyond the statistic. Okay, so once again, the p-value is telling us the areas under here. So if we have the area is split under here, here the area is all at 1 and all at 1, so that's once again why they talked about the twice the area here on a two-tail within this. So what do we do? Well, we have a nice flow chart here. We have our start. What type of test are we performing? Okay, is it left-tailed, right-tailed, or two-tailed? Okay. Once we decide that, then we can kind of see what's going on. If we go to that left tail over here, we talk about the p-value is an area to the left of the test statistic, and then once again we'll relate it back to our significance. Two-tailed, in the center here, we talk about is a test statistic to the right or left of the center of this. So we have, is it here, is it over here? And then right tail relates out over to that right side. P-value equals the area to the right of the test statistic. So caution. Do not confuse the p-value with the proportion p. Okay? P-value equals a probability of a test statistic at least as extreme as the one obtained. P equals a population proportion. Okay, so once again, don't just go P equals, it's our p-value is what we're relating to on here. So that's once again one of the p-value in here. So critical values is another way to look at this, a little bit more of a traditional method. When we find our critical values, we separate the critical regions. Okay, so once again, this is where we start talking about within here that if we have our 98% confidence, 99% confidence, what was that z-score or t-score that would be relevant in here, and then was our test statistic value then higher or lower than that. So that's kind of where this starts in here looking at. So if we look at step 7 is to make a decision about this. So we basically have two options that we start looking at. We either reject our null hypothesis or we fail to reject the null hypothesis. Notice we are not doing any claims towards our alternative hypothesis. Even though we have one, we are not claiming anything with it. So the p-value method, if p-value is less than or equal to alpha, we will reject our null hypothesis. If the p-value is greater than alpha, then we'll fail to reject that null hypothesis. Basically, this kind of relates directly over to that critical method. If the test statistic is in the critical region, we reject it. If the test statistic is not in the critical region, we fail to reject it. So basically what this is saying is that on this overall curve, if what's ever happening happens in that critical region, that means that null hypothesis is not going to happen, that it can't be true at all. That's why we reject that null hypothesis. But if we see that, oh hey, our null hypothesis is over here, so once again, if I come up here I can see a little better. So our null hypothesis is showing over here. Well, now it's showing, hey wait, it's not critical. So we can't reject that null hypothesis. So that's where we say we fail to reject it. Whether it be this area technique or if it's just if you're actually looking at what's going on here. Okay, so on table 8.3 right here gives us some nice words to go with this. So we start talking about the original claim does not include equity and you reject the null hypothesis. So there is sufficient evidence to support the claim. So we're supporting the claim because our claim we're actually referencing was part of our alternative hypothesis. Okay? Once again, the original claim does not include equity and you fail to reject. So there is not sufficient evidence to support the claim. Now, if our original claim is part of the null hypothesis where it's showing equality, this means there is sufficient evidence to warrant rejection of the claim, or there is not sufficient evidence to warrant rejection of the claim. So once again, if our claim falls with the null hypothesis, we're either not going to reject it because there's evidence, or there's not enough evidence to reject it. But if our claim is with that alternative hypothesis, that's where we'll either support it or there's not evidence to support it. So kind of all this really comes into the fact that whatever happening, the term accept is misleading. Okay, so in this text we'll be using terminology of fail to reject instead of accept the null, and then we'll be wording things carefully within. So if I kind of come down here, there's this nice caution. It says never conclude a hypothesis statement with a statement of reject the null hypothesis or fail to reject. Okay, so what's ever going on here, that fail to reject or reject the null hypothesis, is a statement that we just use. But what we really want to do is we want to state our conclusion back to what our claim is. Okay, and so as we go through examples, you will see this a little bit better. Okay, so once again, the null hypothesis is not always what we have for our claim. Sometimes that alternative hypothesis in here. The next part we start talking about is they bring up type 1 and type 2 error. Okay, so type 1 error, basically the mistake of rejecting the null hypothesis when it's actually true. Okay, so the symbol alpha is used to represent the property of type 1 error. And then in type 2 error, the mistake is failing to reject the null hypothesis when it's actually false. Okay, so basically what happens here is the mistake rejecting, so basically we could state that yes, that this truly does equal, but in our test we rejected it. That gives us a type 1 error. Type 2 error says, well, we reject it when it's actually true. Okay. So some of the things they start relating to down here in this statement or the true statement of nature table down here. We talk about the null hypothesis is true, type 1 error or correct decision. We fail to reject null hypothesis, correct decision, or it's a type 2 error. Okay, once again, depending upon what's happening in here. And then once again, go through, read some of the examples as we discuss this. So when we have our comparison in here, they have a nice little statement on the bottom of page 407. It talks about a confidence interval estimate of a population parameter contains the likely values of the parameter. We therefore reject a claim that the population parameter has a value that is not included in a confidence interval. Okay, so here they kind of give you a little caution thing that you're going to want to read through. In part 2, we go talking about beyond the basics of hypothesis testing and talk about the power test. So the power of hypothesis test is the probability 1 minus beta of rejecting a false null hypothesis. The value of the power is computed by using a particular significance level alpha and a particular value of the population parameter that is an alternative to the value assumed true in the null hypothesis. Okay, so what we start referencing here is we start saying that just as 0.05 is a common choice for a significance level, the power of at least 0.8 is a common requirement for determining that the hypothesis test is effective. Okay, so once again, this power test kind of starts relating to is the hypothesis test itself even worthwhile? So this kind of sums up. We don't do too much with part 2 on here, so don't feel too overwhelmed. And as we start going through examples, you're going to be seeing a pattern of what continues in here. So our next part is going to be looking at the patterns.